topic that we are starting now is circle proofs. So to get started on circle proofs, first thing we need to know is a couple of definitions. So first, a statement that is universally accepted without needing to prove is called an axiom. So kind of, like a fact that you know is true. Other statements are true once you have proven them to be true. And then once you have defined them, you can then use them to prove other statements. So the aim of this topic is to use these two things, so axioms and definitions, or defined statements, to prove other statements. Many proofs require us to prove that triangles are congruent or similar, and then use this information to prove required statements. So before we get started, make sure you're familiar with what defines a congruent triangle or a similar triangle. So congruent triangles will have SSS, all sides equal. Similar triangles will also have SSS, all sides in the same ratio. Okay, so making sure they've either all been scaled up by 2 or reduced by 3, as long as it's all happened to all sides. Next, congruent triangles will have side angle sides. So 2 sides equal and the angle between them, that's important, the location of that angle, is the same. Similar triangles the same, except we just say the sides are an equal ratio rather than saying that they are equal. Angle, angle, side, so we need 2 angles equal and the corresponding side congruent, so the same. In a triangle, similar triangle, we only need 2 angles equal, because obviously once 2 angles are equal, the last one must also be equal because angles add up to 180. And then finally, that we've said in the past RHS rather than RAHS, right triangle with congruent sides and hypotenuse. So you need the right angle, the hypotenuse side, and one of the shorter sides. Okay, that doesn't apply to similar triangles. Prove that the line joining the centre of a circle to the midpoint of a chord is perpendicular to the chord. So one of the trickiest things about this is just getting familiar with the language and what this diagram would actually look like. So hopefully you all did the introduction package on circle theory just to remind yourself of all this language. So I would always start with a diagram if they don't give you one when we're doing proofs, just so we can see what it is we're looking at. So we've got our circle, we've got O as our centre. A chord is just a line that is drawn from one side of the circle to the other. Obviously you would avoid trying to do the diameter because that will get confusing when we're doing things later, so make sure it's just somewhere not in the way. Give yourself, anytime you make those connections, make sure you label it. So we label the centre O, we'll call the first point A, first point B. And then it says we're going to draw a line from the centre to the midpoint, so we'll call that M. And because that is the midpoint, then that must mean these two sides are the same length. So AM and BM must be the same length because it says we're joining the circle to the midpoint. And now we're going to try and prove that this is a perpendicular angle. Now, nearly always triangles is what you're trying to make because we know those facts about congruent and similar triangles. So once we've got those facts, or got those axioms, then it makes it easy to prove what it is we're trying to do. So once you've labelled everything, got your triangles, think about what it is we need to show. So what the way we're going to show that this is perpendicular is by showing that these two triangles, so triangle AMO and BMO, are identical, because if those two triangles are identical, then these two angles here must be the same, and if they're the same, they must both be 90, because that is a straight line. Okay, but we can't just say that, we have to show using our axioms and our defined statements that this is true. So let's go through this. So as also, before I start, remember that because we are proving something, your working is the most important thing. because they've already told you what the answer is. So the steps that you show are the most important parts of the question. So making sure you're really clear about what you've defined and then what the reason that those things are true. Okay, so the working that I'm about to show you from now would be the working that you're expected to show on your page. So this is what you would put in your book, in your writing. In triangles, so that's the triangle symbol, AOM and BOM. Again, making sure you're tracing them the same. So see how we've gone from the circle to the center to the midpoint, and then again for BOM, circle, center, midpoint, you must trace them the same way, otherwise they're not the same triangle. We need to show our statements and give a reason. So first statement, AM is BM. How do we know this? Because M is the midpoint. OA equals OB. We know this because they are both the radius. OM is common in both, so again, must be identical. So using what we know from our previous slide, we know therefore those two triangles are congruent because side, side, side. Next, what we're trying to do is work out that angle. So now, because we have proven that they are congruent, that must mean the two angles, AMO and BMO, are the same. And again, like we said, that means they must be 90 because it's 180 degrees split into two. And we know that because they're corresponding angles and they add to 180 degrees. And then usually once you've finished your proof, you say QED, or you can say proven as required. Right, example 2. Prove that the angle at the center is double the angle in the major arc. So we already practiced doing this, but now we're going to prove why it is true. So we're doing the sketch again. Again, label some points. We're going to go A, B, C around there, so that's the major arc. So we want to know that A, B, C is the angle on the arc. Remember, subtended just means between, so between A and C. And then we've got the next one, we're trying to find the angle here, AOC, and we're trying to prove that this angle is half of this angle, which we have used, we've been told that it's true, but we've never proven it to be true, so this is what we're going to set out to do. So again, draw the sketch, think about what we know, and now we're going to think of our plan. So we've got to somehow break these into triangles, then start labeling things, and usually with proofs, guys, it just kind of flows. So you've just got to get, just by just starting to label things, sometimes it just becomes more and more obvious. So let's make some triangles. So we've made triangle AOB and triangle COB. So what do we know about the triangles that we've created? We know that AOB is isosceles because AO and OB are both the radius. So then because we've got an isosceles triangle, we know this angle here and this angle here is the same. And so let's call that X. So rather than having to write the angle every time, let's just call that X. So then we know this angle at the center, so angle AOB, is going to be 180 take 2x, because we know a triangle had to do 180 and we already have two x's. Next, let's do the same thing with the other triangle. So again, COB is isosceles, since again CO and BO are the radii. So again, those two angles must be equal. Let's call them y. And so COB is 180 take 2y. So if you notice, what we've done is we've defined this angle here, AOB, and we've defined this angle here, COB. So now we can define this angle using the full revolution. So AOC is going to be 360 take AOB take COB. Because again, as we just said, a complete revolution is 360. So those facts are important. Make sure you say why you're doing what you're doing. So that must mean, once we simplify everything, we can see the 360 is going to get cancelled by the 180 and the 180. So we're just left with 2x plus 2y. Then we can define angle ABC, because we said this was x on this side and this was y. So angle, sorry, you might not be able to see that behind the bits of the PowerPoint. So angle ABC is x plus y, and AOC is 2x plus 2y. So therefore, we have shown that it is double. Okay. All right, last example for this set of slides. Prove that the size of x, so the x there, is 20 degrees. So we've been given a diagram this time. We don't have to draw it, but we have to prove that this is 20, given that the only information we've got is this angle here is 70. So again, we need some points, so we've got something to refer to. So we're going to say ABC. All right, what do we know? Well, we can use what we learned in the previous proof to now use to prove our new statement. So we've already proven now that the angle at the center is going to be double the angle at the circle for a subtended between the same subtended points. So AOC must be 140. We know that because an angle at the center is double the angle in the arc. Next, we know AOC is isosceles because AO and CO are both the radii. So then OAC and OCA are identical because they are an isosceles triangle. That means they have to both add to 40 because this was 140. We know triangles have to add up to 180, so all that's left is 40. That must mean x equals 20. And that's shown as requested. Okay, so like I said, it's just a matter of thinking about what you know, being really clear. So remember, it's a proof. For those of you who hate showing working out, proofs for something you're going to have to practice. You've got to be really clear in what the working is, what your reason is. And because a lot of these won't have answers, because it's just saying proven, what I want you guys to do is, as you're doing these questions, if you're not sure of getting them right, take a picture, send them to me. I'll look and see if you're on the right track. But make sure you're getting the hang of these because they are an important skill to be able to master. All right, so this should be enough to get you started on 5A, so have a go at those questions. Like I said, send me pictures if you are getting stuck and I'll give you a hand. Otherwise, enjoy and good luck.